Hello, everyone, and thank you very much for joining us today for our introductory webinar, Starting Vibration Testing with RULA Technologies. We're going to be talking about just the common test profiles today, but we're hoping to be able to make this time interesting and worth your while. And just a few words about the technical side of things. I hope you can hear me. If there are any problems with the sound, please let us know in the questions section. The question section can be found in your toolbar, so you can just unfold questions and type them in. And all through the presentation, you will be able to send your questions, and at the very end, we will leave some 15 minutes in order to try and cover them all. My name is Elena, and I'll be moderating this webinar, and my colleague Philip Stumscheis, software engineer, will be making the presentation. We also have here the head of software development, Ilya Sokolovs, the head of software development for RULA Technologies, and he will be answering any tricky questions that you might have. So the question section is in your toolbar. Another tool you may want to use is raise your hand. So also find it on your toolbar. And if you like, you can raise your hand and we will enable your microphone and you will ask your question out loud. But also, please, we're asking you to wait till the end of the presentation. Now we're ready to move on to the content part. Just a brief overview of what we're going to talk about today. So we will talk about the common ways of setting sine, random, and shock profiles in RLC21 and RLC25 vibration control systems. We'll give you some tips and tricks of how to do it best, how to maximize your testing experience. We will also talk about some new features that might be of interest in these particular test types. And we're also going to draw your attention to some pitfalls and common mistakes that you don't want to make so that your vibration testing experience is enjoyable and easy. And without further ado, I'm going to pass the microphone to my colleague who's going to give the presentation.
Hello, let's start preparing for vibration testing. Our first step is to set up our system. As you see in this picture, we need to connect our computer with RLC21 or RLC25 controller. We should do this with an Ethernet connection. After that, we connect our amplifier with the first output channel of our system. When the connection is set, we connect the shaker and the amplifier. After that, we should mount our accelerometer or other type of a sensor on the shaker stable. Then we connect an accelerometer with the first input channel of our system. In the next picture, you will see the connected system. Here you can see our computer, our RLC21, RLA 200 amplifier, and our Tira shaker. I think now we are ready to start creating vibration tests. Let's open this probe cell. Oh, I see a question here. I have no sound. Oh, I think I'll try to make something with your sound. Oh, I'm glad to see it. Let's continue now. Now we open this probe cell. So the first step in vibration testing is to configure your system. We open Configuration tab and choose Channels. For this test, we're going to create a new configuration, so we press Add button, and let us call it webinar. So now you can see our channels, and the first channel will be a linear input. Its sensitivity will be 100 millivolts per G. And as the second channel, we will select our sensor from the database. So we click here. Sorry, I can see another question. I'm glad to help you. We will select a charge sensor from our database. We double click, and now you can see that the sensor parameters are pasted in the fields. Here you can see sensor name, its sensitivity, type, and serial number. It is worth mentioning that sensor name, serial number, and check date are optional, so you don't have to put them every time you create a channel configuration. There are some common mistakes while you're creating channel settings. For example, you must enter the correct sensitivity according to the sensor's passport. Another usual error is mistakes in sensor type. For example, if you have an APE sensor, you can't set it as charge. In that case, you'll receive errors. So our configuration is done, and we are ready to continue. We apply settings and press OK. So we open Shaker's database. For our tests, we're going to use Tira, and the model is TV51110. Here you can see the Shaker's frequency range, masses, limit values, and the Shaker is also selected as the default one. You should remember that displacement of the shaker is set as 0 peak, 0 to the minimum point and 0 to the maximum point. If you enter displacement as peak to peak, you'll receive errors during your tests, and it may cause system damage or so on. So I recommend you to enter values really carefully. So this shaker is selected, and now we are ready to create our tests. We go to main tab, and the first test is going to be Sine. We're going to create a new test, so we press create test button. And here we see the first tab, it's profile tab. We're going to use the DO160 standard for this test. This standard is used in aircraft and helicopter landing gear. So let's enter the profile. Our first input will be start frequency, it's 1 Hz, and the start amplitude of 1.27 millimeters. I can see a question here. I think now we don't have Dynalabs shakers in our database, but there is an ability to add them there. You can add the manufacturer, the shaker settings, and also we have a video on our YouTube channel where you can find answers to all your questions about shaker and settings configuration. So we're going to continue to enter our profile. The end frequency is 14 Hz, and the end amplitude is also 1.27 millimeters. Our profile is rather complicated, so we are going to add another line. The end frequency is 24 Hz, and we will recalculate our start amplitude by changing the measurement unit. So it's 1G, and here we also write 1G. We add the third line. Here you can see that we have an out replacement function enabled. So the last frequencies of the lines insert to the start frequencies of the next line. So in this line, we will also recalculate values, and the end frequency of the third line is 74 Hertz, and amplitude is 0.43 millimeters. Oh, sorry, I should recalculate it. We add the fourth line. The end frequency is 141 Hertz. Here we'll have 10G or about so. We add another line, and here I'll show you one trick. If we want to have our start amplitude in millimeters and end amplitude is set in G, so as you can see here, we can use calculate point of intersection button to calculate the end frequency. We press this button and you can see that our end frequency is calculated. We add our final line, set end frequency to 2000 G, and amplitude is 20 G. Our profile is done. Now I'll show you another interesting function. If you want your test to run, for example, 5 minutes or 5 hours, you can edit time to demand time text box. For example, I'll enter the value of 300 seconds, which is equal to 5 minutes, press recalculate, and you can see that the sweep rate has recalculated. The next step, we're going to set our channels. We go to Channels tab and select our webinar configuration as the default one. I think for this test we're not going to use the second channel, so I will disable it. After that, we should check our shaker. We go to Limits tab and see that our Tira TV51110 is selected. Now let's set the schedule. I want to have sweep from 10 Hz to 1000 Hz. We apply settings, save our test. And here we see acceleration versus frequency graph. After that, it's worth mentioning that there are some limit values which are calculated according to shaker and schedule. For example, in this test, we have acceleration maximum value of 20.45 G, velocity of 0.20 meters per second, and displacement of 1.27 millimeters. The background of these values is green, so that means that these values are between 0 and 70% of shaker limits. If these values are yellow, that means that these values are between 70 and 100% of shaker limits. You can run such tests, but you should be very careful. If the value is red, you are not able to start these tests. Limit values exceed shaker limits, so it's rather dangerous to run such tests. But if you want to run such tests, you should disable check for shaker limits. But we recommend not to do this because all damage and problems will be at your own risk. So we're gonna start our test with this checkbox selected. We apply our settings, see that we have acceleration versus frequency graph, and now we are ready to start the test. We can see that this test is starting up, and now let's create some graphs. We are going to create a THD versus frequency graph, and another one will be transmissibility versus frequency. Here you can see that the test is running, and the graphs are dynamically drawn. Also, I want to tell you about transmissibility versus frequency graph. It is widely used for resonance searches and it's rather useful. Also, we have some interesting features which can be shown on graphs. For example, we can create some data cursors like this, and you can see that the current data is shown here. After that, we will create another horizontal cursor line, some nodes. For example, we will call it node 1, place it here, create another one, and we'll make this node fixed. And place it here. As you see, when I rescale the graph, the node 2 is placed on its start position. Also, you can add parameters as nodes. For example, I choose first channel acceleration, and here we have its running value. Also, we can arrange graphs in different ways. First of all, we tile them vertically, then we can edit them horizontally, we can put them into a cascade, or use adaptive view. You can see that our test is running correctly, so I think now we can stop it and continue with another type of test. The next test will be random, and I have a pre-created test. It was made using mil STD standard, so let me open it. RULA R&D mil STD rail. So we are going to open test settings. And here you can see that our profile is set as points. We can see here 4 points, 1, 2, 3, and 4. But if you want, you can set your profile as a table. To do this, close this tab, go to configuration, open default settings, and uncheck enter random profile by points. We have another function which will be shown here. During random tests, we can select show PSD in decibels function. It is also used widely in some different standards, so our customers asked us to make this function, and here you can see it's done. We apply settings and go back to the main test settings tab. After that, we will check our channels configuration, select webinar, disable the second channel, and check our limits. Our shaker is selected, so we can continue. We go to Control tab, and now I will tell you some information about averaging results. Here we have 2 different averaging algorithms. The first one is DOF, and the second one is CDOF. DOF is a usual way of averaging. It uses real spectrum, and it's the main way to average your results. But also we created CDOF. It uses for averaging results of short tests. It's quicker and you can get more smoother results. Now we can apply our settings and start running our test. You can see that the start goes, and before the startup is going on, I'll create some graphs and tell them tell some information about them. The main graph for random test is spectrum density versus frequency. As you can see, it is shown in decibels, as I selected. And we can also create some exotic graphs like probability density and cumulative probability. All these graphs are useful for data analysis, and you can also check the test running states. So you can see that the test is running, and let's stop it and go to shock tests. We open shock, and we also have a pre-created test according to DO160. We open, we go to our shock and open its settings. The first tab you see in the shock test settings is pulse. Pulse consists of different parameters. The main parameter is pulse. It has pulse duration, pulse amplitude, and pulse type. It describes the main shock, as you can see here. Also, we have a pre and post pulse. Pre-pulse is the state where the shaker moves its stable to the lowest point before the shock, and on post-pulse, the shaker moves its stable on the 0 point. So here you can see our profile according to the DO160. Then let's check our channels. It is webinar. The second channel is disabled. We check limits, and here you can see one interesting feature. We have abort and tolerance settings, which you can set according to different standards. As you can see, we have MIL STD 810, DO, and so on. We have a DO 160 test, so we select this one, and our shake is selected. And now I'll show you on the graph about abort and tolerance settings. We can select, for example, MIL STD, apply, and you can see that the graph has changed. But we have another standard, so I'll put back the O. In this example, I want you to show the functionality of drawing SRS graph, so we should enable this function in SRS parameters tab. To do this, click do SRS calculation. And now I think our setup is done and we can start creating and running our test. We start the test and we will also create some graphs. We can create acceleration versus time, velocity versus time graphs, also peak velocity, spectrum, and SRS graph. We will create acceleration versus time. I think you are all familiar with this picture. If you're interested in standards and know about the DO160 standard, we will also create SRS versus frequency graph and spectrum graph. I think it's the main information you should know about shock tests, but now I'll tell you about some interesting features you can apply according to your task. You can go to oh, sorry, my mistake. You go to Control tab, and here you can see two interesting functions. First one is called Use Saved FRF. If you have a sequence of tests which are common, for example, you want to run this DO160 shock for 5 times, you press Use Saved FRF, and in that case the startup will go faster and you'll get your results better. Also, you should be sure that this function is selected only in case if you have the same system when FREV was measured. For example, you mustn't change shaker, sensors, and so on. Another function is called use single shock. It's shown here. When your test consists of a small number of shocks, for example, 3 or 5, we can use this function to disable startup shocks with the level equal to the test running state level. It will improve your test results, and it's a rather useful function. I think that's all information about shock, random, and Sine tests for today. I think I've mentioned all interesting features we have. And now I pass the word to my colleague Yelena.
Yes, Philip, thank you. As I said, that was just the introductory webinar, and I can assure you that moving forward, we're going to go into more detail about each test type, because the system is quite sophisticated, so we have a lot of functionality that we want to let you know about. And now we have time for your questions. So just let me look to the question section and see what you have asked. So talking about the shakers that you want to add to the database, yes, that's absolutely no problem. You can add them yourselves. But we are also constantly updating the database, and in the oncoming release of the software, which is going to be, I think, in about a month, we're going to have more shakers in the database. We're going to add new models upon your requests. So yeah, we're going to make it more convenient for you. That's no problem. Then another question. What TEDS templates do you support?
I think that we support 2 TEDS templates. It's TEDS template 25 and 27.
I would also like to add that when we do calibration of sensors, we can also rewrite the information on tests for these procedures. Okay, let me see. There is another question. How do you create reports? Okay.
I'll show you the report creation in this test example. The first way to create a report is go to test settings, open your schedule, add create report command. So at the end of your test run, the report will be created automatically. And another way of creating reports is here, it's shown on the main tab. You can edit your report settings, edit report folder, select the graphs which will be shown in your report, and so on. Also, to create report, you can press this button.
Okay, let me see if we have more questions here. Just a second. So do you have an embedded charge amplifier?
Yes, we have an embedded charge amplifier, so you can use it in your tests.
We also have a question. Is it possible to export data for post-treatment, and how is it done? What are the export file extensions available? So for this one, let me just give the microphone to our head of software development. He will give you more details.
Yes, of course, it's there is a feature to export data to the post analysis, and there are two ways to collect such data. First of all, we can write all the samples using the data recording function in our own VAUFX format. However, the format can be read in MATLAB or in any software because it's free, and we can give you procedures of reading the data from the file. Besides, if you are interested in the data from the graph, you can just select the line, then press Ctrl E, short K, and save all the line data like this one in a CSV format. And so when I open this file, yep, just a second, it hung somewhere. So I will have like two columns. One is for time in seconds and one is for acceleration. So I think that's all. Just a second. So here is another question.
Yeah, another question is the interest in more advanced items in control of each type of test. Yeah.
About the control parameters in random test. All the control parameters can be there are two types of control parameters. First of all, we can select any combination of channels to be a control. So we can control using one channel or two channel, three channel, four channels, etc. If there are more than one channel, the channels can be combined using either some average weighted sum or by selecting minimum or maximum from the channels. And the next group of the parameters is based on the control tab. It's sample rate, resolution lines, window type, etc. However, usually the user doesn't have to change something on this tab.
Okay, we thank you all for your interest, your involvement, and your questions. Everything that has not been covered yet in the answers, we're going to follow up with. So you will receive a follow-up email with a video of this webinar and detailed answer to your questions. And we will also, as I said, continue the webinar practice and go on into more detail about every type of test. We're very interested to know what you would like to learn about. So we're going to send you the questionnaire forms, and we're hoping you will be willing to participate in this questionnaire and choose out of the range of subjects which ones you would want us to cover in our oncoming webinars. Thank you very much for joining us today. I hope this was helpful, and we hope that you're going to join us in the oncoming RULA events. Thank you and have a nice day.